Hey everybody, this is Mr. Bells here coming at you. This is information for section 7-3 in data analysis. We're dealing with multiplying and dividing rational expressions. So multiplying and dividing rational expressions. Your ability to be able to factor is really going to be huge in terms of being able to work with these ones. And we're going to talk about what is allowed, what isn't allowed when we're done. Okay? Several example problems coming your way here. So we're going to start off with something that looks just like this: x squared plus 7x plus 10 over x squared minus 4. If I want to do this division, the first thing that I need to do is I need to break it apart and see what it's made up of. So I know that the top factors into x plus 2 and x plus 5. And again, if your factoring skills are a little less than desired, you can always go back and look at some of my videos on factoring and go that way. So this is over x plus 2 and x minus 2 in terms of the factoring. So anytime that you're doing division like this, once we've broken them down into their parts, then we can go, if I have something times something and something times something, if you have the same things, either the top and the bottom, then they can cancel each other out. So my final answer is going to be this: x plus 5 over x minus 2. And we also have to define things that are not allowed. So x is not equal to 2 or negative 2. And that comes from right here. The negative 2 comes from this one, because negative 2 plus 2 would be 0, and you can't divide by 0. And if I put in here a positive 2, right, so the opposites of what is in here, that can't equal 0 either, because 2 minus 2 is 0, and 0 times anything is 0. Okay, so not only are we going to write what the final answer is, but we're going to define what we're allowed to have or not allowed to have in those problems. Okay, so that would be a factoring situation. This one, we're going to factor like a dentist first, see if we can do anything with that. Okay, so this, I'm looking for stuff that comes out of the top and the bottom, because right now I can't just cancel out these x squareds. It doesn't work like that. I have a subtraction sign right here. These are two different terms. Can't do that. The only time I can do cut off tops and bottoms like this is if it's just multiplication. You can have pluses or minus signs in the middle of those terms that are being multiplied, but you can't have separate terms like what are up here. Okay, so it looks like on the bottom I'm able to pull out a 2x. Okay, and that leaves me with a 7x minus 3. And on the top, I have an 8x squared. Well, if I'm going to then do this, 8 over 2 is 4, and x to x squared is x. So I'm going to have 4x and 7x minus 3. So 4x over 7x minus 3. Now, again, what is not allowed, or what's not part of the domain of this original function? We know right here, when we factored it out, x can't equal 0. That's from that term. And x can't equal 3/7. So the opposite of this number over whatever that number is. So those are two things that it can't equal there. Let's go to this one right here. This is a little bit more stuff going on. So I got two fractions. I got this fraction over here and this fraction over here. But because it's multiplication, we can kind of just string that all the way across. And again, you should take down any notes that you can, watch any of the stuff that you can. Pause the video anytime that you're not sure about something. Okay, so let's go ahead and see if we can knock anything off. Well, I know that I can cancel out that with that, right? Can I cancel out this x squared and this x squared? The answer is a big ol' honkin' no. You cannot do that. This has a minus 4 with it, so this is two terms. It's not grouped together, just an x squared separately. But I can break this apart into x plus 2 and x minus 2, because that's a difference of squares. And then this x minus 2 and this x minus 2 cancels. And it looks like I have a total of x cubed on top. And then downstairs, looks like the only thing I got left is that x plus 2. Good deal. Where x can't be negative 3, right? Can't be negative 3, or 2, or negative 2. Can't be any of those. -3, 2, or -2. Okay, so I'm going to come down to this one. This one's, as you can see, it has no pluses or minus signs. So that means everything here is multiplication. So I can just do one of two things. I can start cutting them out in the very beginning, or I can rewrite them together. I'm going to rewrite them together this time and go from there. So I got 16x to the 4th, y to the 4th. It's multiplying the numerators together. In the denominators, I got 24x to the 4th, y to the 5th. Looks like then that x to the 4th kills x to the 4th, y to the 4th kills y to the 5th with a single y still downstairs. And 16/24 I believe is 2/3. So 2 divided by 3y, final answer, where we know that x can equal 0 and y can equal 0. Those are our two things that we can't have because those were in the denominators. So that's kind of how some of these things are going. There might be some problems in the homework that require more factoring, but the factoring that you see right here is the same stuff that you're going to do. You're going to break them apart, and then you're going to knock off stuff that you can that's on tops and bottoms, and then tell me the stuff that's not allowed. Okay? So next section of this stuff is division. So what does it mean to have division of fractions? And for some of you it could be scary, but I'm going to tell you this. All we're going to simply do is we're going to take that division symbol and we're going to copy dot flop. Okay, so that's kind of what the little saying goes. So copy, we're going to copy the original one, 6x squared y cubed over 4x squared y. Copy the original fraction. Change this division symbol into a dot, which means it's multiplication. And then flop this one on this head, flip that fraction. So copy dot flip if you want, I don't care. 6xy cubed over 2x squared y. So it's going to look just like this. Now this one looks the same as number 4 above. Okay, except this time I'm going to go through and I'm going to just knock them off as we go. So I have x squared and x upstairs, so that's 3x's upstairs and 4x's downstairs. That leaves an x downstairs. I have 6y's upstairs and 2y's downstairs. That leaves 4y's upstairs. And this 6 kills that 2 and leaves a 3. And this 6 reduces with that 4 and leaves a 3 over 2. Looks like I got a 9 upstairs and a 2 downstairs. There we go. Where again x can equal 0 and y can equal 0, because that would give us division by 0 in the denominator, which is impossible. Okay, so I got 2 more example problems for you guys to try on these ones, or to look at as we go through here. And again, remember, please stop the video, slow it down, whatever you need to do to help yourself out. Okay, so here we go. Division symbol again, so copy dot flop. So x squared plus 6x minus 16 over x squared minus 64. Dot, change the division to a multiplication, and flop x squared plus 16x plus 64 over x squared plus 5x plus 6. Oh my gosh, this is big. This looks scary. And it is, unless your factoring is awesome. So here we go. Let's factor. X minus 8 and x plus 8. Here we go. X plus 2 and x plus 3. That looks pretty good there. This one up here, x plus 8. Is that? Yep. And x minus 2. And this one over here, x plus 8. And, another x plus 8. Okay, so those are the factorings of those ones. So now we get to have our little battles, our little fights, and see what we get out of this. And I thought maybe a whole bunch of stuff would go because they're close, right? But we really only can knock off this one and this one. And That's it. I mean, we're close, right? But that's a plus and that's a minus. I can't cancel out those. That's a minus and that's a plus. I can't cancel out those. So it looks like my final answer is x minus 2 in the numerator, x plus 8 in the numerator, x plus 8 in the numerator. Downstairs, x minus 8 and x plus 2 and x plus 3. So it's a big cubic over a big cubic, where x, of course, can't equal 8, negative 8, negative 2, negative 3. None of those things. Can't be any of those things from my flipped fraction. Okay? This one right here, 1/2 x plus 2 equals 3/8 x. So this is a solving one. This goes back. This is just kind of check your stuff. But I threw in a practice one for you guys to be able to do it. Now you could change it and try and just change them to decimals if you wanted to. But we're going to deal with fractions just because I think it's good for you to deal with fractions. So step number 1, I'm going to move this 1/2 x over. So now I get 2 equals 3/8, or 3x over 8. Whether you want to put that x on the top or side by side, that's fine. Minus x over 2. So I want common denominators here. So I could multiply top and bottom of this by 4. So that'd be 4x over 8, right? X over 2 is the same as 4/8 x. So now I have 3x over 8 minus 4x over 8. So 2 is equal to negative x over 8 times by 8. 16 is equal to negative x. X equals positive 16. So that's a solving for that one. And you can check, right? Watch. Check that. Shove it into here. 1/2 of 16 is 8. 8 plus 2 is 10. Yeah. Right? And then 16 divided by 8 is 2. 10 times 3 is 6. Oop. That didn't work. What do we do? Let's double check again. So see what I just did? I got x is equal to 16. Yeah? Look at that. X is equal to negative 16. Man, that's kind of important, isn't it? So sometimes I'm going to do that specifically because I want you to be precise, right? Over on my board, ATD, attention to detail. So let's try it now with a negative 16. So 1/2 of negative 16 is negative 8. Negative 8 plus 2 is negative 6. So my left side of my equation is negative 6. Now negative 16 divided by 8 is negative 2. Negative 2 times 3 is negative 6. Check mark. Yes. It made sense. It worked. Very good. So again, this is BIM, Mr. Bells. I'm multiplying and dividing rational expressions. Hope this video was beneficial to you. Again, if you're having trouble with factoring, please look on my website under factoring practice videos, and that should be of great help to you. Okay, we'll talk to you later. Bye.